Welcome back to another SolidWorks tutorial. In this video, we are going to create the complete flange couple assembly. We are going to start off by modeling the individual parts. We create the individual parts, the flange A, flange B, the bolt, the washer A, washer B, the bush, and then the nuts. Then we assemble them and finally create the exploded view. For more SolidWorks complete assembly tutorials like this, please subscribe to the channel and turn on post notifications. And let's begin. So first and foremost, you're going to create a folder. The name of the folder will be Flange Couple Assembly. This is where we are going to save our individual files. Then you open the SolidWorks software. We are creating the first component, which is the flange A. It's a parts component, so when you click on parts, it takes us to the SolidWorks part modeling workspace. You're going to use the revolve tool. So we just sketch half of this section view and then revolve around the horizontal axis. So create a sketch on the front plane. Get our horizontal axis to be this horizontal line. And then make sure it's a construction line. Then you draw half of the profile. Let's dimension it. The full length here is 255, which will be the diameter of the outer circle. And this is 140. So click on this line and the center line. When you move your cursor outside, you can see we can dimension the full diameter. That is 255. And click on this line. And this is 150. Okay, 140. 58, 32. Okay. Sketch is fully defined. Exit. Now make sure the sketch is selected. And then you're going to revolve. So use the revolved boss base. Okay. The direction is blind. And then the angle is 360 degrees for a full revolution. Okay. Next, you're going to create this cut inside it. Use the extruded cut. Click on this face. And we draw a circle on this origin. The diameter of the circle is 40 millimeters, as we can see here. Okay. The end condition, set it to up to next, or better still, through all. Okay. Next, we create the circular holes on this face. So this time you're using the hole wizard legacy hole. The type should be a simple hole and the diameter of the holes 31 millimeters. Set the end condition to up to next and come to positions. Click on this face. First of all, we get a circle that will be a constructional circle to guide us where the centers of the holes will be. Draw a circle. And the radius of the circle is 95, hence the diameter should be 190. Click on it and make it a constructional circle. Then you place the first center of the hole. We use the point tool and place the point on this point on the circle. Then you are going to circularly pattern the hole. So we get 8 holes in total. So we come to circular sketch pattern. The hole has been selected. And then the point we are patterning around will be this center point here. We need 360 degrees, dimension radius, and we need 8 holes in total. Okay. To make the sketch fully defined, just click on this vertical line here, make vertical, fully defined. So, okay. The last thing you are going to do is to change the appearance of the flange. So come to edit appearance. Under the appearance, you go under the metallic appearance. We use a chromium plate. Okay. Now save the part, and you're going to save it in the desktop in the folder that we created, Flange Couple Assembly. This is the first part, flange A, and then save. Next, we create the second flange, which is the flange B. So create a new file, a new part file, okay. And you're going to use the same method we used in creating the flange A. So first create a sketch on the front plane. We get our center line. Make sure it's a constructional line. Then we draw half the profile. So with the same dimensions, this is 255, this is 140. This is 19 and this is 70. Press escape if it gives you this dimension again. Now we can dimension this. Sketch is fully defined, so exit. Make sure the sketch is selected and revolved boss base. Yes. With an angle of 360 degrees. Okay. Then you create the hole. So with the extruded cut, click on this face, draw a circle. Diameter of the circle is 40 millimeters. The end condition, set it to through all. Okay. Again, you are going to create circular holes. So with the hole wizard, legacy hole, the type is a simple hole, and the diameter of the holes 16 millimeters. Set the end condition to up to next. Come to positions and click on this face. Again, you are going to get a guide circle. And the radius of the circle is still 95, so a diameter of 190, just as we did for the flange A. And then you make it a constructional circle. Place the first center here, and then circularly pattern it to get 8 circles in total, or 8 holes. Okay. To make it fully defined, because this is underdefined, click on this line here, make vertical. Sketch is fully defined. Okay. Then again, we change the appearance to a chromium plate. Okay. And save the file as the second component, flange B. Save. Next, we create the third component, which is the bolt. So create a new file. You're first going to create the hexagonal head of the bolt. So create a sketch on the right plane, and it's going to be a hexagon, that is a polygon with 6 sides. And there's no length on this hexagon, but looking at this not hexagon here, it's 21, so that's what we are going to use. And make sure this is a vertical line, so click on it, make vertical. Sketch is fully defined, so exit. Make sure the sketch is selected, extruded boss base. We are extruding by a distance of 7 millimeters. Okay. Then we smoothing this face, so click on extruded cut and this face. Draw a circle in this center, and we make sure the circle is tangent to these edges. So press the Control key, click on the circle and just one edge, make tangents. Sketch is fully defined, so exit. And then you're going to flip the side to cut. Add a draft of 45 degrees angle. Okay. Next, we add this extension. We're going to use the revolve tool. So we sketch just half of the profile and revolve around the horizontal axis. So we create a sketch first. The sketch is supposed to be on the front plane. So we first get our center line. Click on it and make it a constructional line. Then we draw half the profile. Let's dimension it. This is 35, this is 45. This diameter is 19, this is 16. So click on this line and this center line, move your cursor outside, 19. This is 16. Sketch is fully defined, so exit. Make sure the sketch is selected, revolve boss base, yes. An angle of 360 degrees, okay. Then we add the thread. So the thread has a pitch of 2 millimeters, and the entire length is 25. And we are going to use the 16 diameter, but we are going to cut inside. So use the thread feature. You have to select the start location of the thread, select this edge, and the end location of the thread, select this edge also. By looking at this thread, there is an offset from here. So the offset distance should be 45 minus the 25. $20 millimeters. So we have to add an offset to the start location of 20 millimeters. And then for the end location, we also add an offset so it can come inside for a perfect thread on the edge here. So an offset of 2 will be okay. Since it's a shaft, we go with the metric die type. If it's a hole or a nut, we use the metric tap. And the diameter of the thread is 16, the pitch is 2. We use the cut thread. Okay. And then finally, we change the appearance of the bolt. So come to edit appearance again. And this time we are going with the brass appearance. Okay. So now save the parts. This will be the third component, the bolts. And save. Next, we create the fourth component, which is the bush. Create a new parts file. And you're going to use the extrude feature to create the bush. We create a sketch on the right plane. We sketch 2 circles and dimension the diameters. So the outer diameter is 31 and the inner diameter is 19. Sketch is fully defined. Exit. With the sketch selected, click on extruded balls base. And the length of extrusion is 30 millimeters. Okay. And then we change the appearance of the bush. So the bush should be a copper material. So we use a polished copper and save the part. The fourth component, bush. Now looking at the 2 flanges, we can see there are these chamfers that we forgot. So we can open file to the flange A and then add the chamfers to it. So the first chamfer should be 2 by 45 degrees and the second should be 1 by 45 degrees. So click on this edge. Okay. And you add the second chamfer 2 by 45 degrees on this edge. Okay. And then save the parts. Then you open the flange B. And again, we add another chamfer to it. Chamfer of 1 by 45 to this edge. Okay. Again, save your parts. We move on to the fifth and sixth components, which are the washers. So create a new file. Just as we did for the bush, we are going to sketch 2 circles on the right plane. The outer diameter is 30. The inner diameter is 19.5. And the distance of extrusion is 3. Exit. Extrude balls base and the distance is 3. Okay. Then we change the appearance to a brass appearance. Okay. And then save the parts. This is the fifth component, washer A. This will be the washer for the bolt. And then you create the second washer. Again, you create a sketch on the right plane. 2 circles. The outer diameter 30, inner diameter 16.5, and a distance of 1 for the extrusion distance. Exit. Extruded balls base and a distance of 1. Okay. Then you change the appearance to a brass, polished brass, and save the parts. This is the sixth component, the washer B. Save. Then you create the last component, that is a nut. You create a new file. First, create a sketch on the right plane. So we draw a hexagon, a polygon with 6 sides. And make sure this is a vertical line. The distance between these two vertical lines is 21, just as we did for the bolt. Then we add a hole of diameter 16 millimeters. So we draw a circle of diameter 16. Sketch is fully defined. Exit. Extrude boss base. And then the total width of the nut is 10 millimeters. So, okay. Then we smoothen the edges. But since we are smoothing both edges, come back to edit feature. And then the direction, we are going to use a mid plane. So we can just smoothen one edge and then mirror onto the other side. So with the extrude cut, just as we did for the bolt, click on one face. And then we draw a circle. And make sure the circle is tangent to the edges here. Exit. Flip side to cut and add a draft of 45 degrees. Okay. So this is the smoothened face. And select the cut extrude and mirror. And then the mirror face or plane, we use the right plane. Okay, so this is why we extruded using the mid plane. So we can just mirror onto the other side. Then we add the thread, basically the same thread dimensions as on the bolt, a pitch of 2 millimeters and a diameter of 16, covering the full length. So with the thread feature, the start location of the thread, click on one edge here. The end location, click on this edge. We can add offsets of 2 millimeters to both edges. Reverse the direction. And again, add an offset of 2 so we can have perfect threads through the nut. Since this is a hole that a shaft will enter, we use a metric tap. Dimension of 16 by 2. The 2 is the pitch distance. We cut thread. Okay. Finally, we change the appearance of the thread also to a brass appearance. So polished brass. Okay. And then we save. This is the 7th and the last component, the nut. Rebuild and save the document. Next, we are going to assemble the individual components that we have created into the final assembly. So create a new file. This time we create an assembly file. Okay. So this is our SolidWorks assembly workspace. And then these parts have been opened here because we have not closed any of the parts. They are all here. That's why they are opened here. So I'm going to first display the origin of the assembly workspace. So come to hide all types, this eye icon, view origins. And then you're going to insert our first component. So come to insert components, flange A. So click and then move your cursor here. Click to release. Now the first component that we insert in SolidWorks is fixed by default. So if you want to make it float, you see we cannot move it. The selected component is fixed. It cannot be moved. So right click, float. And now we can move it and rotate it anyhow we want. So you're going to make these two origins coincide or merge into one point. So under meet and under the standard meet, we use the coincident meet. Click on these two origins. Okay. Now right click and fix it. Now we can see the assembly is fully defined. And we can hide the origin. Then we insert the second component, which is a flange B. insert it here. The first mate we are going to add is the concentric mate between these two holes. They have the same horizontal axis, so you make them concentric. So click on these two holes. Okay. And again, we have to align two holes here because this, as we can see, is rotating. So again, with the concentric mate, I will zoom in, click on this hole and this hole. Okay. So there is no rotation again. And then finally, we use the coincident mate to merge this face of flange A and this face of flange B. Okay. Now the assembly is fully defined. Now we insert the next component. We insert the first bush. So click on the bush and drop it here. Again, we use the concentric mate because the bush should enter this hole. So click on this face of the bush and then this face of the hole. Okay. Now you can see the bush enters. Then we add the coincident mate between this face of flange A and then this face of the bush so that the bush can enter the flange A. Okay. And the bush rotates inside the flange. So in order to stop rotation, to make the assembly fully defined, we lock the bush and the flange. Okay. So the assembly is fully defined. After locking the bush, you have to insert washer A and then the bolt. So insert components, washer A. Again, since they are all circular features, we use the concentric mate. And then this hole and this hole should be concentric. And then you make sure this face of the bush merges with this face of the washer A. And again, there is a rotational motion here. So we lock the bush and the washer A. Okay. Fully defined assembly. And then we insert the next component, which is the bolts. Since this is a shaft entering, again, we use the concentric mate. And then this shaft and this hole. Okay. And then you make sure this face of the bolt is coincident with this face of washer A. Okay. Again, there is a rotational motion here. You don't want the bolt to rotate, so lock the bolt and the washer. Okay. Fully defined assembly. Next, looking here, we add the washer B and the nut. So insert component, washer B, and then again we use the concentric mate. Between this face of the bolt and then this face of the washer. Okay. And then you make this face of flange B and this face of washer B coincide. There is a rotational motion here, so we lock washer B and flange B. Fully defined. And then we insert the last component, which is the nut. So with this nut, we are not going with the normal concentric mate. we want to give it a screw motion so it can tighten and then loosen. So this time we go with the mechanical meet, a screw meet. We use a distance per revolution, and the distance per revolution is simply the pitch. By what distance should we move in one full revolution of the nut? So that is the pitch. So the pitch should be 2 millimeters. And then we want to make sure the axis of the nut and the bolt are showing. So view temporary axis. And then we select this axis of the nut and then this axis of the bolt. Okay. So when you click on the nut and then rotate it, you're either screwing it up then finally we have to set the limits in which the nut should move. So under advanced meets, we use the limit distance. And we have to set the limit between this face of washer B and this face of the nuts. So the maximum distance should be 25, as we can see here. And then the minimum distance should be 0 because we want to start here and end over here. So the maximum distance or the maximum value, 20. Okay, actually 25. And then the minimum distance should be 0. Okay. And we can disable the axes that are shown. And now we can rotate so that when you get to the maximum limits, the screw will not move again. But we can now come back. So when you get to this minimum distance of 0, the screw doesn't move again. And screw it back. And again, when you get to this limit distance, the screw doesn't move again. So you are done with the first link between the flange A and the flange B. You can do it manually for the other holes, but that's going to take a whole lot of time. So the best thing we are going to do is to just pattern in a circular manner. So we come to circular components pattern. In the components to pattern, we pattern this bolt. Click on the bolt, washer A, washer B, the nut, and then come here and select the bush. Now for this direction, we can select any circular face. So you select this face of the flange B. And then we need 8 patterns in total, an angle of 360 degrees. Come down and check the synchronized movement of flexible subassemblies. Okay. You can see the assembly is fully defined. So yeah, this is the final assembly of the flange couple. Finally, we are going to create the exploded view of this flange couple assembly. So come to exploded view, and then we start the explosion step 1. So the steps in an exploded view are simply the parts we are going to move. So the first part we are going to move in this assembly is the nuts, because that is the last component that we added. So since this nut here is just one component, we don't have double nuts. Let's say we have 2 flanges here. So we are going to move the 2 flanges together. But for the nut, we are just moving 1 nut. Even though there are 8 nuts in total, we are moving just 1 nut. So we go for the regular step and then click on all the nuts. And then we use this arrow to pull the nuts back to a distance of 150. Done. Then we move on with the second step, which are the second parts. So we move the washer bees. So click on all the washer bees. And then with this arrow, we pull them back. Done. Move on with the third step. The third step, you're going to pull out the bolts. So again, we click on all the bolts. And then pull them out. Somewhere here. Done. Next, you pull the washer ace. So not this flange. And then pull them out. Done. Next, you pull out the bushes. And then finally, we pull these 2 flanges apart. So since there are 2 components that we are pulling apart at the same time, we are going to use the radial step. And then click on these 2 flanges and move them apart, just as we can see. You can see this is different from the regular step. This is a radial step. Done. Okay. So this is how our view is going to be like after we explode. And then we collapse together to form the final assembly. So in order to get the exploded view animation, you come to this property manager. Under this exploded view, right click, animate collapse. And then you can right click and then animate explode also. You can fast play it. And you can even slow them down. It collapse. So basically, that is the end of this flange couple assembly. Thanks for watching. If this helps you out, make sure you subscribe and then leave a like on this video. Turn on post notification so you do not miss any upload. And I'll see you in the next tutorial.